Most tanks of the Second World War were locked into a single fuel type, and when supply lines shifted or ports were bombed, those tanks sat useless. What made the American M4 Sherman so effective wasn't just mobility, numbers, or reliability. It was the engineering philosophy behind its power plants. Shermans weren't built around one engine. They were built around whatever the Allies could get their hands on. In fact, engineers designed the platform so that factories scattered across North America could install entirely different engines: gasoline, diesel, radial aircraft engines, and converted aviation engines, without changing the core of the vehicle. This wasn't improvisation, it was a deliberate logistical strategy, and it explains why the Sherman kept moving across Normandy, Italy, North Africa, and the Pacific while other armies watched their armored forces stall for lack of fuel. Today we're digging into how this flexibility was engineered, why it worked, and what it meant on the battlefield. The secret starts with modularity. Sherman wasn't one tank, but a family of tanks with interchangeable power plants. American engineers didn't actually design just one perfect engine. Instead, they came up with a chassis that could accept several different engines depending on which factory was building the tank. At the same time, the United States was producing thousands of aircraft, naval vessels, trucks, and generators, right alongside its tank program. Fuel demands were, honestly, pretty chaotic. So, rather than forcing tank builders into a bottleneck, the Ordnance Department just told engine manufacturers, "If you can produce a reliable engine, we will adapt the Sherman to fit it." This whole approach led to the major variants of the Sherman. The M4 and M4A1, for example, often used radial aircraft engines. Those were converted from Wright-built 9-cylinder units that were originally meant for airplanes. Then there was the M4A2, which ran on twin General Motors diesel engines. The M4A3 used the Ford GAA, a massive gasoline V8 that was, interestingly, first designed as an aircraft engine. And just to add to the variety, there was even the M4A4 with a Chrysler multibank, which was created by linking 5 automobile engines into one power plant. All of these engines, well, they burned different types and grades of fuel, but what really tied them together was the engineering mindset: build the tank so that fuel flexibility actually becomes a logistical weapon. So, why run tanks on gasoline when diesel seems like the obvious choice today? Well, it's because the American industrial machine was, really built around gasoline production. The U.S. oil industry in the early 1940s produced enormous quantities of gasoline for vehicles and aircraft. Diesel refining capacity was, honestly, comparatively small. Rather than redesign the entire national fuel infrastructure, engineers built tanks around what the nation could reliably supply. Gasoline engines also brought some pretty important acceleration advantages. Crews noted that gas-powered Shermans reacted quickly when maneuvering, something that was absolutely critical when facing ambushes or anti-tank guns. Diesel Shermans, like the M4A2, existed mainly for Lend-Lease, because allies such as Britain and the Soviet Union already had extensive diesel supply chains. So, the key benefit of multi-engine production was really strategic. No single supply disruption could cripple tank production. German tank factories, on the other hand, depended on just a few engine types, mainly Maybachs for Panthers and Tigers. If the Maybach factory was bombed, the entire tank programs would slow down. The Americans deliberately avoided this vulnerability. Factories in different states could install completely different engines and still produce standardized Shermans, with interchangeable parts for everything except the power plant. If gasoline shortages hit one theater, diesel Shermans were shipped to another, and if aviation fuel stocks ran high, radial engine Shermans could burn it with little modification. Engineers weren't just producing tanks, they were producing insurance against industrial collapse. On the battlefield, this flexibility translated into endurance, repairability, and constant availability. Sherman engines were remarkably maintainable, not because each one was simple, but because their compartments were designed to be serviced quickly. Crews could swap power plants in the field with a crane and a trained team. Armored divisions often had spare engines on hand, something impossible with German heavy tanks. Fuel flexibility also meant Shermans kept moving even when air power ravaged supply lines. If gasoline convoys were delayed, units with diesel Shermans still operated. If aviation fuel stocks were abundant near an airfield, radial engine Sherman units refueled without interrupting operations. Historically, this design philosophy helped define the Allied war machine. The Sherman was never meant to be the most heavily armored or the most powerful tank. It was meant to be everywhere, every day, in every theater, regardless of supply conditions. The multiple engine strategy allowed the United States to supply allies, adapt to climate conditions, and dominate operational tempo. While the Germans produced masterpieces, the Americans produced solutions. This is the part of the Sherman story that rarely gets the attention it deserves. Engineers chose fuel flexibility as a weapon, and, well, history proved them right.